Okay, so on page 7, check this out. Let's go talk about what this means before we even go to our calculator. It says, where is f increasing? Where is a function increasing? What do we know? A function is increasing when, instead of its, what's f prime is positive, right? If my f prime is positive or my f prime is greater than 0, that's when my function is going to be increasing. So let's go take a peek. Let's go look what they gave us, f prime. Let's go to our graph. So let's go to our graph, and we're going to just graph f prime because we just wrote when that's positive. So I'm going to go up here. I'm going to say, all right, my f prime is x plus 2e to the negative x all over x squared plus 0.7. Boom. And then if I were you, I would graph what we got just so you have that. Because these are your notes. This will help us, like, how the heck did we get our answers? Our graph looks something like this. Correct me if I'm wrong. It's like, woo, something like that. So this is a graph of f prime. We're saying if this is f prime, so if I were you in my notes, I would say this is f prime and here's its graph. Just a sketch of it. Where on this graph are these f prime values positive? Say it again. He's saying everywhere. If my f prime values are positive, this is an f prime graph, positive values just mean it's above the x-axis, right? Every point has to have a positive y value. And Ritzy said the entire time these y values are positive. You're right, Ritz. This is above the x-axis the entire time. So which region would you say my function is increasing? Yeah, negative infinity to infinity. They're trying to trick us. I think that's a tricky question because you're like, wait a minute. The function is decreasing here, but this is f prime. We're looking for when these f prime values are positive. If I looked at the slope here, I agree the slope of f prime is negative, but that'd be getting me f double prime. So yeah, this one I think is interesting. For every x from negative infinity to infinity, this graph is above the x-axis. Okay, let's try this next one with a calculator. It says derivative of g is given. Again, they gave us g prime, and they said note my window. And it says, where is g decreasing? So before I do anything, I'd be like, all right, a function is decreasing if it has negative slope. So let's go look at that slope graph because they gave us slope. So I'm going to go back to my y equals. I'm going to say cosine of pi x squared. And I'm going to change my window because they told us to change the window. Instead of my x-min of negative 10, I'm going to go negative 0.5 to 1.5. And then my graph, tell me, does yours look like mine? Ish? Yeah? Okay. So then I'm going to just sketch, and if I were you, I would sketch it as well. Looks like my graph is something like this. And that is g prime. And they ask, where is g decreasing? Well, I know g is decreasing when g prime values are negative or less than 0. This is g prime, so when is g prime negative? When is blank the x-axis? Below. G prime is negative when the g prime graph is below the x-axis. So how would I find out, whoa, I didn't mean to do that. How would I find out boom to boom, what these two red points are? Yeah, those are zeros, y'all. So let's all go to our second trace. Option 2 is zeros. You got to go to the left of the 0, to the right of the 0, and we're going to have to do it twice probably, unless you were just looking at the region. Man, I can't find my little cursor. Come on, little cursor. You're getting closer. Okay, here we go. All right. So to the left, enter. To the right, enter. I got 1.224 as this one over here, comma 0. That's this one. And is that going to help me? Yeah, I wouldn't have to take it any further because I know it's got to be 1 point to this, and my 1.224 is there. We agree in C. Did anyone get the 0.707 when you checked it? Awesome. We doing okay with it? All right. This one I said, all right, I gave you f prime again. Ooh, this one is not calculator. I don't think. Yeah. So I gave you the graph because I'm kind. Okay, never mind. It just says, where is f increasing? Okay, and there's going to be two regions here. F is going to be increasing when when F prime is positive. Oh yeah, can you not see? I understand why. It's a terrible picture. Sorry about that. So it crosses the x-axis at 0 and at 4. And this is a graph of f prime. And that's what they told us above. This is a graph of f prime. My function f is increasing when f prime is positive. Where would we say? Okay, sir. Yeah. I just love how you threw some likes in there. Like you didn't want to be too serious about it. It's like negative infinity to 0 and like 4 to infinity. You're so right. That's perfect, dude. Negative infinity to 0 and from 4 to infinity. You could have also done brackets on the 0 and the 4 if you wanted. They'll take either one. If we don't get a calculator, it's going to say, when is my function increasing? You're like, okay, that's when my f prime is positive. So we can do this without a calculator. Let's go find our f prime. My f prime would be 4x cubed plus 2x. We done with that? Okay. This is something new. I didn't realize that we were doing this today, but here we go. Okay, for something to be positive, do you agree that it's got to be bigger than 0? So this ties into what we did yesterday. Yesterday we found critical points. And yet critical points, and Cooper, this will be good for you. Critical points are where your f prime is equal to 0 or it's undefined.
And where it has a vertical slope or whatever.
Or a cusp or a corner. Well said, Cooper. Okay. This is where potentially maxes and mins can happen. Why do I care about maxes and mins? What's my function doing here?
It changes direction.
It's increasing, right? What's my function doing here? Decreasing. And then it was increasing and now it's decreasing. So when my f prime equals 0 or is undefined, that's going to help me figure out where it was increasing till or decreasing till. So in order to figure out without a calculator where my functions are increasing or decreasing, we got to go find those critical points. And that's what we practiced yesterday. Let's go find those critical points and let's remind ourselves. A critical point, I don't know why I made that one word, is when f prime is 0 or f prime is undefined. And a critical point is going to help us figure out where a function is increasing or decreasing till. Kind of those landmarks. Okay, so let's go find this guy's critical point. When does this equal 0? What would we be able to factor out here?
2.
A 2 and a x. Well said. Leaving me with 2x squared plus
2.
1? Is that right?
Yeah.
Okay. When do each of these equal 0? When does 2x equal 0? Yeah, and when does 2x squared plus 1 equal 0? Ew. When we have to subtract 1, divide by 2, and then take a square root of a negative, guess what we don't have to do this year? Imaginary numbers, square roots and negatives. We didn't have to do them in pre-calc because we don't have to worry about them in AP Calc. So any square root of negative, you can always just ignore it. Don't care about it. So this only has the derivative equals 0 at 0. We also need to know my critical points are where my f prime is undefined. Would a nice cubic graph ever be undefined?
No.
A function is only undefined when its denominator equals 0, and we don't even have a denominator here. So we only have one critical point here. Whoo-wee, this is a good Friday. Okay, here's what we got to do without a calculator. You put your critical point on a number line, and maybe we'd have multiple critical points, but I say that's my critical point. This is like a little number line. I'm going to put that in a little box because that's what's going to dictate my answers. Guys, that is an x-coordinate. I know that this is a little funky. We're going to plug that into my first derivative to see what my function is doing. And what we call this is an SIGN chart, a sign chart. We're going to figure out signs. And you'll see, like, this is a lot on the first problem, but as we keep practicing, we'll get better at it. But don't feel like, oh, I had to be able to do this right on the first problem. No, we got to practice this a couple times. So again, seeing it on a Friday is good because then we'll really dig in on Monday. Okay, what is the number to the left of 0? -1 or?
1.
No, to the left. Negative what? Yeah, anything negative, right? So I'm just saying if Tatum put -5 and Ritzy put -1, great. Either one works. What number do we want to put to the left of 0? -1. I'm down with that. Anything to the right of 0 on a number line. Sure, 1, but if Tatum put 100, good. Tatum, what's your basketball number?
34.
We could put 34 over there, okay? Here's the deal, you guys. This is saying the only critical point, the only place that we might have like a max or a min or that's going to dictate what our function is doing is 0. So this is the only place that something could be happening. So anything to the left, you can plug that number in. You can plug this number, -1 or negative anything, into your f prime. You could plug it in up there, but me personally, I'd plug it in once we have it factored because life is going to be easier. You're going to plug this number in over here. And all I care about is it positive or negative? What would plugging in a -1 do right here? Positive or negative? I don't even need the value. 2 times -1 would get me a negative, times -1 squared would make it positive times a 2 would keep it positive, plus a 1 would keep it positive, right? So if I had a negative times a positive, do you agree this value here would be negative? And you're like, what the heck are we doing? Well, you just said anywhere to the left of 0, my f primes would be negative. If my f primes are negative, wouldn't my function be decreasing? If f prime is negative, my function's decreasing. So I kind of draw that to help myself see what's going on with my function. Then we got to check something to the right of 0, and we picked 1. So I'm going to go plug that 1 into the same spot. And we got to get the sign, S-I-G-N, of what that f prime value would be. If I plugged a 1 in here, do you agree this would be a positive value times a positive value? Positive times a positive is a positive. Therefore, if f prime is positive, what's my function doing? It's increasing. So what do we know? Here, this is the deal. We've just kind of sketched out what my function looks like. My function is going to basically look like a cute little parabola. Okay? So there is a minimum when x is 0. Agreed. Now, look what they asked, though. They said, when is my function increasing? Oh, does an x to the 4th graph look like this? Yeah, ish. Okay? So when is it increasing? Do you agree my function is increasing anywhere to the right of 0?
Yeah.
Right.
What has to be C?
So we would say from 0 all the way to infinity. I agree, buddy. Whoa, but I want you to know we just did a ton in that problem. We just did a ton, so we will be practicing that a ton. I got you, buddy. You're welcome. Okay, that was a lot. That was a lot. Let's back it up and let's try again because this is a lot. Whew, okay. All right, you guys. For g to be decreasing, for a function to be decreasing, what's its derivative have to be? Negative. For g to be decreasing, g prime has to be negative. Here's what we got to go do. Let's go find g prime. G prime of x is what? 3 times the 3rd. 1x to the 2nd plus 3 halves times 2. Those 2's are going to cancel. 3x to the 1st minus 7. Great. You guys, in order to figure out if g prime is less than 0, you always have to go find those critical points. And those critical points are where g prime equals 0 or g prime is undefined. Let's go find out where this equals 0 first. Toot or O-toot? Toot. What multiplies to be negative 70 adds to be 3? 10 and a 7. 10 and a 7 multiplied to be 70, and they're 3 away. Which one's negative? 10 and a 7. Yeah. The 7 will be negative. I love it. So we got x plus 10. Sorry. X minus 7. Does that sound right? Where are my critical points, y'all? 7 and negative 10. Those are my critical points. Critical points are where my g prime equals 0. Found them! Or when my g prime is undefined. Is cute little x squared plus 3x minus 70 ever going to be undefined? No, because there's no denominator to equal 0. We're good. You guys, here we go. We got to practice this sign chart again. We got, whoa, negative 10 and 7. I like to put little boxes or circles around them because that's what's going to dictate my answer. Look over here. Do you agree 10s and negative 7s are used? The numbers that we pick in between will not be part of our answer. So I just like to specify those are my values. And I like to say those are x's. I'm going to plug them into my f prime to see what the shape of my function is doing. I realize this is a lot. Bear with me. Right. Give me a number to the left of negative 10. negative 20. I bet a lot of you chose negative 11. Both are great. A number between negative 10 and 7, go for it, Ava. 0, I dig it. A number bigger than 7, go for it, Marmar. 20. Okay, I like it. You followed the Rai. Give me an example, like negative 20 and 20.
Just the 0 in between the 10. Like that doesn't change anything. I didn't realize you put it up.
You saying, can we use 0 because of this 0 up here?
No, I'm just.
This is new. Here's what we got to do, you guys. We're going to plug in negative 20, a la my girl Rai, into my f prime. Again, I would go into my factored f prime because me plugging in negative 20 here is just like a lot of math that I think is harder than plugging in negative 20 here and here. These are both g prime. Okay, you guys. Negative 20 in the first set would make this positive or negative. Negative 20 plus 10. It would be a negative, times negative 20 minus 7 would be a negative. So a negative times a negative would make this f prime positive. If my f prime is positive, what's my function doing? Increasing. So I'm going to be like, ooh, my function looks like that. Now I'm going to go plug in 0 into my g prime. Right there and right there. 0 plus 10 is positive. 0 minus 7 is negative. A positive times a negative is a negative. And that means that my function, if f prime is negative, my function is decreasing. Lastly, if I plugged in this 20 into the same g prime, do you agree we'd get a positive times a positive? Positive times a positive is positive. If f prime is positive, my function is increasing. You guys, they asked, when is my function g decreasing? Oops, I should have done g's here instead of f's. You get it, though. My function g would be increasing. I could even draw what it would look like. Increasing, decreasing, increasing. Do you agree that that general shape is what an x cubed graph looks like? We know an x cubed graph looks like this. This sign chart just helped us find out where those maxes and those mins are. My function is decreasing. Wouldn't you agree from here? I'm going to put it in yellow. Okay, I'm just going to highlight the blue in yellow. From where to where is it decreasing? Again, these are x values. Negative 10 to 7. Is that an answer? Boom. I love them. Here we go. Another multiple choicer. 2003.
Crazy.
Let f be the function with, ooh, they gave you the derivative this time. Where is f decreasing, but without a calculator? We got to know when is f prime less than 0. And you guys, and every time we got to do this, you always find your critical points, and that's when f prime equals 0 and f prime is undefined. And they gave us f prime, so that's kind of a gift. Let's go see when my f prime equals 0 first. That's going to get me a critical point to put on my sign chart. What would you do first? Any ideas? Well, I can't take a... Oh,
You'd have to multiply by x.
are you saying multiply by x again to get rid of that denominator? Yeah, we could do that. So what if we, because denominators are the worst, right? So could I say times x times x times x? So then we'd have an x cubed minus a 2x equals 0.
It would be 2.
Oh, it would just be 2. Thanks, Dean. It would just be 2 because those x's would cancel. Let's go find it. When does x squared cubed equal 2? What's my critical point going to be? Cube root of 2. I don't have to do plainness when it's an odd exponent. Okay. Does this make you feel kind of okay? Because I see a cube root of 2 in some answers. So you guys, that's when my critical point equals 0. Will my f prime ever be undefined?
Yes.
When x is 0, right? Wouldn't 0 make that denominator 0? So we've got critical points at 0 and at cube root of 2. So you guys, those have to go on my sign chart. 0 and cube root of 2. Again, I like to box those. Those are what my answer is going to be based off of, not the things in between them. Okay, Lob, what number do you want to give less than 0? Negative 3. Between 0 and the cube root of 2, which are like, I don't know what the cube root of 2 is. I don't either. That's fine. What could be at something?
0.1.
0.1, I think, is a great guess because you're like, I'm going to hug the 0 because I'm not quite sure what the cube root of 2 is. I'm fine with that. Anyone else have a different guess? Yeah, you'd be comfortable with 1 as well. Because if I did the cube root, which is option 4 of 2, we get 1.259. So just an idea. So bigger than the cube root of 2. Again, if you're like, I don't know what that is, go drastic. Be like, okay, I'm just going to pick 10. You know what I mean? Or 100. We can pick 100 if you're like, I don't know what the cube root of 2 is. You guys, we go plug that in to my f prime. So these are x's. We're going to plug those into my f prime to see what my function is doing. -3 into my f prime. My f prime is up here, so I'm going to draw a little arrow. We're going to plug that in there, over there, because we never really factored it out, or I guess we could have plugged it in here too, but I think we'll be able to do this. -3 squared would get me 9, right? And then -2 over -3, wouldn't that be a minus a negative would make it positive? So 9 plus something's just going to be positive. I don't care what the amount is, but f prime would be positive. If f prime is positive, then my function's going like this. Pew! Increasing. Okay, this one we might have to think a little bit. 0.1 squared. It's positive, but it's going to be a pretty small number, right? Minus 2 divided by 0.1. So if I've got 0.1 squared,
Be negative.
it's going to be negative because a number divided by a smaller number is going to get us a bigger value, right? So 2 divided by 1/10 is really 2 times 10, which is 20. So 0.1 squared is going to be little, minus 20 is definitely going to get me a negative number. If f prime is negative, my function's decreasing. And then what if I had 100 squared, huge positive number, minus 2 100ths? It's going to be positive still, right? 100 minus 2 100ths. It'll be a nice positive number. If my f prime is positive, my function's...
Wouldn't it be 2/10, right?
Well, we chose 100 down here. Did you put 10?
Yeah.
Yeah. So you would have had 10 squared, which would be 100 minus 2/10 would still be positive, right, buddy?
Yeah.
Cool. So my function's going like this. Woo! There's my function. They want to know where is my function decreasing? From what x to what x? 0 to the cube root of 2? D it is.